Hello, this is Alicia from Women Who Code Philadelphia presenting Building a Digital Career, Job Hunting and Networking in a Digital World. Just a brief overview of the technical interview process, and I've gone full on PowerPoint, full on purple for today. We start off with resumes and applying to jobs. Everyone starts here, and I'm going to talk a little bit about this process. I'm not going to talk about resumes. I'll allude to it a little bit, but there's so much you can talk about just in this tiny box. I'll touch on a little bit. Next is the initial recruiter call. When you've applied to a job and a recruiter reaches out to express interest, you have a conversation, and that's something where you can learn a bit, the company can learn a bit before you move on to the next stage. I did a talk on the initial recruiter call for one of the other Women Who Code interview prep talks. That's available on the Women Who Code YouTube channel. If anyone's interested, just ping in the chat and I can send that link again. Next, once you've scheduled an interview, you'll usually have 1 to 2 rounds of interviews, sometimes 3. It's not too scary. The 3 interviews aren't like 3 5-hour interviews. The first interview is meant to be a screening of, do you have the basic technical skills? They're not really going deeply into your history. Sometimes it's just really generic. So you'll see the traditional one is a technical phone screen. That's a 45-minute to 1 hour long call where you'll be given a coding question. You'll be asked to solve it. Sometimes they'll give you 2 small questions, sometimes 1 big question. And that's just the traditional, please reverse this linked list. Thank you, have a nice day. The other variants on that are online coding challenges. As companies are having a harder time, finding people to do interviews and they want to scale out, they start using sites like HackerRank. You'll be given a HackerRank link, and that link will expire in a day, and you'll have 2 hours to complete a coding challenge. If you've ever used HackerRank before, it's just like going in and answering a question and hitting that run button. But once you hit submit, it will run a separate set of tests that the company will receive the results for. When the company gets those results, they evaluate it, and then you move on to the next stage. And then the final one is a take-home coding project. This is where a company might give you a zip file and say, can you please implement the rest of this project? And that can be something like you're given a service with a REST API, but none of the endpoints are implemented. And they'll ask you to implement 2 of the 5. And then they'll schedule a follow-up interview for maybe an hour to talk about your implementation and the decisions you made. Those take-home coding projects can be 48 to 72 hours of time. I've seen a week as well. But those are different ways that you might see your initial interview. In some cases, your take-home coding project might be the only one, or depending how big that project was. But usually you go into a full day on-site. Quotation marks are important here because nobody's going on-site anymore. Back a year ago, if you wanted to interview for a company, they would bring you to their campus. So they might fly you out to California to spend a day there. They'll pay for your flight and hotel, and then you go back home after the interview. And those are often 4 to 5 hours of interviews with a lunch break. And those will usually be 4 technical interviews. So you'll be given a coding problem or a system design problem, and then a soft skills interview. And that's where and by the way, full day also is not true anymore, because now that we're virtual, people are splitting up their virtual interviews into multiple sessions, which is actually very nice in terms of maintaining stamina to be sharp for those coding questions. Soft skills interviews can be part of the other interviews. It depends on the company and what they're looking for, but these are called soft skills because they're not measurable like hard data. It'll be things like, how do you handle ambiguity in your job? How do you prioritize features? How do you deal with conflict in the workplace? Not like interpersonal conflict, but I want to present my idea and so-and-so wants to present theirs and we have to discuss it. So that usually happens, and that interview is highly variable depending on what level and what role you're in. So there's going to be some sort of interview that says, we want to know how you work. We already know how you code. Once you've passed all those flaming hoops, you end up in the offer negotiation stage. I did a talk last last time, so earlier this month, about understanding benefits and total compensation. That's related to offer negotiation to be able to compare, but there's more to it, of course. Understanding your offer, the contract itself, what at-will employment means, and negotiating for different benefits. There's a lot more in there to talk about. And then paperwork and references, immigration, background checks, setting start dates. That can be a lot of work. And then you get a job, and that's where we're all heading to. So,
question before you jump. I don't know, like, are you okay, like, with taking the questions when you basically are done with the slide and before you go to another, or you?
Yeah, sure. This is a good time. Yeah.
Yeah. Okay. So, for example, when you mentioned about one of those like technical, like, challenges, and there is, for example, like 5 endpoints, and they want you to like finish those 2, right? From your from your experience, because I believe like we won't be allowed to like use like Google it, right? Like have this kind of support when usually like at work, of course, like sometimes that's where you are, you know, looking for the answers. But from like your experience, to finish some of those endpoints, like looking on the code I'm provided with, like, do you think like it will help like to look through this and try to figure out, because it might be something pretty similar, just with like small difference?
They will sometimes let you use Google. Even in technical phone screens, when I've been on the phone with someone, they say, yeah, go ahead, use Google. So highly variable. When it comes to the take-home coding project, they don't really care if you've looked up stuff. You have to be able to discuss in depth what you implemented.
Okay.
So it's more like, you know, we want to know how you design this. So it's a combination of design and implementation, and understanding. You know, I've heard people where they can't actually get the project to run. And so, for example, if you're building, you know, a node service and you are great at JavaScript, but you can't get the server to run, that tells them that maybe you don't have the right skill set. So the take-home coding project can evaluate more like, what's this person going to be working like? Yeah, you have access to Google, but can you actually do it? So don't think that you have to like implement a full service without having any resources. That's not gonna go.
Okay.
Oh yeah, thanks for the question. I will grab the links to the other talks in a bit. I didn't have them ready, but they'll get on the meetup and in chat before the end of this. All right, so talking about digital career. I know that there are a few people in our community that are really superstars at having a digital career and networking, being available on Twitter, LinkedIn, chats. I find it really impressive. I personally do what I can, and I'm happy to share the little things I know, but there's so much to this, and you can make it your own. So I'll talk a little bit about the concepts here. So if you're brand new and you're like, how do I get to know people and find jobs when I can't go to career fairs anymore? Hopefully this helps. So I have my smart art here, and I have created this visualization because I'm going to talk about it in a certain way. So there's applying to jobs, which is a kind of a small gear where you can lead up to networking and then up to having a digital brand. And I'll explain these. But I'm showing them as stepping stones. They don't have to be linear. You can do one and none of the others, or a little bit of digital brand and not much applying to jobs. You can customize this for whatever you want. For the sake of this, I'm going to treat it like leveling up. So level 1 is applying to jobs, level 2 is networking, and level 3 is a brand. And then level 4 is starting your own company, which I don't have on this slide. So we start off with the job searches, and this is usually the interaction that everyone has with a digital career, whether or not we are working from home or not. So you're going to go to a job site, you're going to search, and you're going to have some sort of resume that you use to apply. What I'm going to show is 2 different triangles, more of my smart art, and they're going to be funnels because you need to be able to prioritize your time. Your digital career is a career. You can't spend time on everything, you have to target it. So you can't fix every bug, you have to mix up your work a little bit. So we have our first funnel here, talking about building your resume. And when I say resume, it's any artifact, document, website that describes what you've done. And before you start searching for jobs, you want to build out this resume. But you want to start with every single one of your detailed accomplishments. When I say detailed, I mean detailed. Like, I used this version of Node on a Mac computer with these IDEs for 6 months on a team of 5 people, and I delivered something in 3 months. I know this seems like a crazy amount of detail that may not become relevant, but if you just track everything you do over your career, it's going to make it easier to build different resumes and apply to different jobs more effectively. So once you have your list of all your accomplishments from school to volunteer work, GitHub projects, whichever your actual job, whatever you're doing, then you start narrowing it down into a resume. And this is where you're able to customize a little bit. If you build your own website and have a LinkedIn profile and have a one-page resume, you can sort of mix and match from what accomplishments you choose and how you present them. And so that can be really helpful, because if you want to have all 3 of those, you don't want to have to redo this entire process each time. And the other important thing is you're going to be sending a single paragraph or a couple of sentences to recruiters or people that you meet online. And so you want to have that elevator pitch ready. So I might be a Java Spring Boot developer that develops in AWS in event-driven systems. And I'll put things on my detailed resume that are like Kafka, EC2, Kubernetes, and I have all these details. But I can't just throw word soup at someone to say, look at all the things I can do. I have to have 1 or 2 sentences that says, I am a Java Spring Boot developer that runs containerized services on Kubernetes and AWS. So that's the first sentence. And then the second funnel that I'm going to talk about is the second sentence of your elevator pitch. So now we have a reverse triangle here. And you want to, so now that you have your targeted resume, or you have a set of building blocks for a resume, you want to decide what you're applying to. What I'm sure has happened to many people in this event is that you panic and then you stay up till 2 in the morning just frantically going through a bunch of Glassdoor results and just apply. Now for me, what happens is I get about 600 emails, not 600, but some annoying amount of emails, you know, thanks for applying, or hi, I saw your resume, and suddenly I'm stressed out because now I have to reply to these emails and I didn't want half the jobs. So to focus your time and make sure that this already stressful process is manageable, it's good to define what your ideal job is and then start compromising so that you look at a job description and say, is this ideal? Is this pretty good? Will I take it? Or do I just not want to apply to this job? Now, of course, you know, everyone needs a job. So being aware of how much you want this job does impact, you know, how much time am I willing to spend on it? You want to do a first pass of ideal jobs and then pretty good jobs and then the lower rank, because it is really exhausting managing all of these emails and relationships with recruiters. Even when, you know, if you do 10 different first round interviews in a month, that is super stressful. And so if it's for jobs that you didn't really feel like taking, it's then you get exhausted and it can be hard to get the jobs that you want. So when it comes to an ideal job, I'll talk a little bit about this, but you know, first half was I'm a Java Spring Boot developer, ... And I am looking for a backend position with a small company, fully remote, using Google Cloud Platform and Kotlin. And so I state my history and then I state what I want. And these 2 sentences, you can throw them to a recruiter. You can put them in a message on one of these hiring sites that say who you are. You can put it as your headline on LinkedIn. It's just a way that you can intentionally grab somebody's attention. So, you know, take the wide triangle of everything you've done and boil it down to a sentence, and then take sort of a narrow vision of what you really want and then try to widen it a little bit to cast a wider net for opportunities. But you want to start off with those 2 concepts before you frantically go through search results on LinkedIn and Glassdoor and then find out maybe you didn't want those jobs. Last thing for this particular slide Going over a few of the different job sites that are available, I talked about a couple of them. So Glassdoor and Indeed are websites that are pretty traditional. So you search for jobs, you can search for companies, you can see their openings. Lately, a trend in the past couple of years has been pay transparency. So some sites will tell you how much you'll be paid a job, a pay range for that job. So Glassdoor and Indeed, Indeed's a little newer. You can search for jobs and apply to them. Then there's sites like Hired, and there's a few coming up where you don't search and apply. You upload a profile that only paying users, paying recruiters can see. And so you upload your resume and you wait. This is a great additional search tool, or a tool if you're not really searching, but you want to see what's going on out there. It's a little bit biased more towards experienced tech people, because it's hard to have searchable content in your resume if you don't have a lot of experience. So Hired can be nice if you just want to throw your resume out there and focus on other things, but it can be a little harder to find junior positions there. Then there's LinkedIn. Again, really similar to Glassdoor and Indeed, but it's also a social media platform. So you have groups, you have posts and likes. And so it's different, because if you apply to a job on LinkedIn, somebody can search for you and see all your posts. So it's, it can be interesting, an interesting dynamic there. Stack Overflow, we are very familiar, most of us, that Stack Overflow is a site to ask questions about why my service isn't running. But they also have a jobs page. Usually with Indeed, Glassdoor, Hired, and LinkedIn, you're seeing full-time positions, very traditional roles. Sometimes you'll get contract roles. But Stack Overflow jobs has a lot more interesting stuff there. Things like freelance, hourly, short contract. So that's just a different style of job that you can look for. But some of the stuff there is a little weird. So maybe be careful if you use those sites. And further along that spectrum, you have sites like Upwork and Freelancer, where it's really just a free market of skilled workers. You bid on projects. So people will say, I need a website built in a month. How quickly can you build it? And you'll see different bids from other members. And that's more of a freelance site. But again, you know, I've seen things like, can you please do my computer science assignment for me? Like, it's interesting stuff there. Okay, so digital networking, I've parsed this into different levels. And when I talk about digital networking, you can be on Slack, you can be on Twitter, LinkedIn, you can be in Reddit forums, Stack Overflow, like everything can be a digital network. The great thing about digital networking is whichever platform you feel most comfortable in, you can network there. So most of us will create a profile, and not everyone does this, but I start lurking. You know, I check out, I join like 50 Slack workspaces or follow a bunch of people on Twitter, and I just read content. Maybe I'll have tiny interactions like I'll like, or I might respond to private messages. And I usually have a private profile. And so when it comes to reaching out, you know, this is still networking. You're still tapping into a network, but you're doing it in a very low energy kind of way. Next, you can put a little more energy in and start participating. So again, you know, you can hit the like button, respond publicly, retweet, respond on threads, but maybe not starting your own threads or content. And you have a public profile, whether or not you want to. So once you start participating, you become searchable by the content, the replies that you're producing. So once you decide to start participating, you might want to make an intentional profile rather than a implicit one. That's just sort of a recommendation. Then you move into leading. And being a leader in a community means you're creating content. You're the one posting those Twitter links, driving discussions, having a really intentional public profile. Like, you are stating what you want, who you are, what you're doing, calling for collaboration. So I'm sure you've all seen people who are leaders and participants, and maybe you've been a lurker once in a while. I'm like that a lot of the time. And so these are kind of different levels, and I try to highlight that these are different energy levels. Right now, everyone has really swaying levels of energy. One week you might be motivated, then the next week, you're looking at another month of coronavirus and you get kind of demoralized. So the reason why I'm phrasing it this way is you can turn it up or turn it down, but no matter what level you are, you're still networking and it's still a good place to be. This final line is kind of more of a business sort of role, like where you're building. You could be running your own one-woman consulting company. You could be a CTO. You could be a technical evangelist. But this is where you're not just participating in a community. You are trying to leverage the network to get customers, to advance your business, to build a community around your business, not just interacting. So that's like extra level up. Mostly as an individual, you may not be doing that, but you might encounter it if you end up in that kind of technical evangelist role at a company. And just to highlight, whatever you have time for is enough. If you see people and they're tweeting 6 times a day about these fantastic JavaScript hacks and you're like, I can't keep up, you don't have to. Whatever you have time for will work. It's really fantastic to just be aware of what's going on in the industry, and that can give you a bit of an edge when it comes to applying to jobs. Next sort of level up guide is having a digital presence and brand. And this is very strongly linked to networking. You can network but not have a profile and not have sort of a brand. When I say brand, I was first told when I was in my 2nd year of being in tech that I have to work on my brand. I had no idea what that meant. I came out of school as a computer science grad. I'd not encountered any marketing, any social media. It was a very confusing statement. But what that means is, how does the world perceive you? And what do your actions say about who you are? And you can have a brand online where you only have a technical Twitter account. And so people are like, oh, this person's technical. Or you have an account where you mix dog pictures and tech posts. And so that's also part of your brand. You're a dog lover that codes. And a lot of the times, if you accidentally end up with a brand, it can be tricky because if you're on GitHub or Twitter and you start linking those two, you want to make sure that you know what kind of things your company is seeing that might want to hire you. It's just something to be aware of. And you can do this intentionally. So first, you're a member. This is kind of linked to lurking, but when you're a member, you're kind of searchable. So someone can say, Alicia has a LinkedIn profile. It's completely blank and has no picture, but this person exists. So that's kind of being a member. And then you end up going into a candidate role. So I'm calling this a candidate role because as a recruiter, I can go to your profile and say, I know a little bit about this person. I can decide whether or not they're a match for the job I want. Being in the candidate category is usually pretty good if you're looking for jobs, just making sure that you can be seen. But often if you have a profile, you're going to get pinged by recruiters. So a lot of people sort of scale back when they don't want to spend a lot of time on this. So it's okay to go back and forth there. And often when you're a candidate, you have either some sort of detailed profile like on LinkedIn, or you're participating in GitHub, and you usually have some way to be contacted. Next is professional. And so when I say professional here, all of us are tech professionals, regardless of how many profiles we have or whether we even have a Slack anywhere installed on our devices. It's more that you are professionally building a brand. So this might be where you're a content producer. So there's someone I follow on Twitter that builds Pluralsight courses. So he is a professional using his brand as Pluralsight instructor to tweet, to get people to watch his videos. And then you might also be interacting with other community leaders. So that's where you might sponsor other brands, so other individuals as part of your brand. So linking those two. And often if you have like this sort of professional level, you're on multiple platforms. So maybe Twitter and LinkedIn, or GitHub and Twitter. So that's sort of where you can level up. And again, you can scale up or scale down. When it comes to digital presence and brand, it is kind of hard to scale down. Like you can just black out and stop posting, but all your content's already there. So I'm always afraid of putting too much out there, but you have to take the leap once in a while and post random things about whatever language you're learning and hope for the best. And then finally, we have this business category. And again, this is where you might be starting your own company, or you're in a leadership role at the company you're at, or you want to be a one-woman consulting company, or maybe you want to hire people for your consulting company. And that's where you're actually like building a business. So you have a site, you have Twitter accounts associated with your business. You're reaching out and trying to advertise your brand actively to people. And just as a side note, when it comes to your digital presence, it can be anything. It can be a Twitter profile, a website, GitHub, LinkedIn. It doesn't have to be all of them. It can be one of them. It can be tiny, it can be big. Again, whatever you're comfortable with and whatever you have time for. So what do you actually need to get a job? And this is a bit of a cop-out slide. So I'm not going to give you step one, start a LinkedIn profile, but I'm going to go over a couple of things to keep you in the right mindset. So be intentional. I went over this a little bit before, but I want to reiterate that you don't want to accidentally fall into creating 6 different accounts and trying to maintain them all. It is really, I don't know, maybe anxiety driving when I see someone posting on Twitter or LinkedIn and I think, wow, they're just posting this amazing content. And, you know, I can't even remember how to, I can't remember how to foreground a process that I accidentally suspended on my computer. It was a challenge I had this morning. And I'm like, you guys are posting about JavaScript and Python. You know, I should do that too. But you don't want to take on more than you can handle because you overextend yourself and you get exhausted. And the second thing is maybe that doesn't actually get you to your goals. If you go back to that, what's your ideal job? If your ideal job is to work at one of the top tech companies and sort of reap the benefits of being in this large organization, GitHub probably doesn't really matter. To be honest, maybe if you apply to Microsoft, it matters because Microsoft owns GitHub. But for Amazon, Google, you know, cool, you have one, but it may not be important for the type of job you want. So be intentional there. The next part is customize this for you. There's a lot of variety. There's a lot of job sites. There's different jobs out there. Whatever, first off, whatever you're comfortable with. And second, you might be amazing at Twitter, but you don't want to do open source, and that's fine. Or it can be the other way around. But try to play to your strengths and try not to be whoever else is on the internet, like be you, and try to make this work for you. Then you'll be effective and energized. Next is try new things. So maybe you have a little bit of extra time and you think, okay, well, I'll try open source, or I'll try using Hired, or I'll try this other job site. Try to mix it up. You might find that there's something you enjoy more about another site. You might think it's terrible and you wasted time. You could end up with a 5-minute lightning talk for the next Women Who Code event. But it's worth experimenting a little bit if you have the time and energy. And finally, take care. Nobody wants to be exhausted for a job interview because they just did 10 hours of job interviews earlier in the week. I have done these marathon weeks of job interviews, and it ended up with lots of tea and throat lozenges, and it's really hard to be heard when you're on a voice call, and it's going to work out better for you. It'll be a better interview experience, and you'll come out knowing you did your best at your best if you take care of yourself throughout this process. And as a final note, this sucks for everyone. No matter what your experience level is, no matter, if you have a job or you just lost a job or you're not really sure where you want to go, this entire process is so stressful. You're trying to decide what you're going to be doing for the next potentially years of your life. It's hard, and you need a job, and it's rough for everyone. It takes a lot of time, and the job interview process is a very strange experience. So keep that in mind. If you're ever frustrated or you think you're never going to get a job, everyone's there with you. the entire technical job finding and interviewing process is hard, unnatural. People hate it. So we're all there with you. All right. Before I move into soft skills, any questions on digital networking? I know that was quick. These are lightning talks. And you'll have a chance to ask questions once we are at the end of the event and not recording. Okay.
Just one thing.
Mm-hmm.
Hi. So first of all, hi. Thank you for giving some approaches that aren't so.
Oh,
it's so difficult when I see people on how there's like job. Please forward this, and it's just like, thank you for providing some alternatives to taking like that more kind of aggressive approach. The question that I have is about looking for a job that doesn't necessarily reflect the stack that you've learned. So let's say you know JavaScript and they're looking for something else, but they're open to you. They're open to people who don't necessarily know that. How do you perform a coding challenge that is not necessarily in your present skill set? And how do you perform these algorithms and things when the people judging you may not necessarily, when you may not speak the same language, so to speak?
They're usually pretty open about that. There are some cases where it's like, we need a Python developer and we will only accept Python developers. But most often, they can accept interviews in any sort of common language. So I interview for a call-in position and I'm a Java developer, or I'll interview for a JavaScript position and I'm a Python developer. They're usually flexible with it because most languages, you can interchange them. So again, occasionally there will be places where, no, we really need a Python developer, but 80 to 90% of the time, you just say, you know, I'm a JavaScript developer and I'm looking for a backend position. And they'll say, are you open to, I don't know, Scala? And you'll say, yes. And in your head, you'll say, I don't even know what Scala is, but you just say yes anyway, and then you look it up later, and that's fine. All right, hopefully I got all of that. And I'll move on to just this one last slide. So Daniella recommended I did a tiny bit on this on soft skills questions. So this is soft serve ice cream. I enjoyed my link there. So once upon a soft skills question, what is a soft skills question? How do I prepare for them? This, honestly, the best way to prepare for it is to do that really detailed summary of everything you've done, because they're going to ask you sort of random questions that seem impossible to prepare for. So like I mentioned before, soft just means it's hard to measure. So hard data is numerical data and soft data is quantitative. A lot of people object to this term because it seems to minimize the importance of this. So take that naming with a grain of salt. And they really want to know, how well do you talk about yourself and your job? So can you talk about yourself and can you talk about your job? And how do you work on your own and work with others? So they want to know, like, is this going to be an employee I have to manage a lot? Like, will they be self-sufficient? Can they debug stuff on their own? Things like that. So a quick example here. Oh yes, how do you respond in common work scenarios? So like, code doesn't compile. What do you do? So often, at least at some of the top tech companies, they'll start off a question like, tell me about a time, or describe a situation when, or talk about a project that. And so you'll start off with something like that. And then you have to go into, they call it the STAR model. I didn't put this on, but STAR, situation, task, action, result. So what was the situation? What were you supposed to do? What did you do? And what was the result? And so you might get something like, Tell me about a time when you had to cut a feature in order to meet a deadline. How do you decide what to keep and what to cut? And you'll say, I was delivering a address form for a website, and I had to cut a feature in order to meet the deadline. So I decided not to implement dynamic error field highlighting, and instead we just had one generic error message on submit, because the dynamic highlighting wasn't critical to getting the feature done. So we decided to do it later, and we were able to deliver on time, and that feature got done as a follow-up. So I talked about, I was building a website in this form. I had to cut a feature to meet a deadline. The result was that it was still successful. And so that's the type of thing that you want to talk about. Even if it's a school project, it's fine. When I've been interviewing school candidates, I will ask things like this. Anyway, so that's a preview of soft skills. This is new to this current presentation. So if you want to hear more about soft skills questions, if this is something you like, please let me know, and I'll try to work more of it in. Now, onto the trees presentation. Daniella, you'll be able to present. I will stop sharing.
Well, hello everyone. I'm Daniella DSouza, and I'm joining you from Dallas, Texas. Can everyone see my screen?
Yes.
All right. So I'm just gonna, welcome. Glad to have you. So I'm a senior software engineer at Heritage Robotics. My elevator pitch, I build containerized Python applications that are deployed on OpenShift. And I'm into data engineering and event-driven architecture. I'd love to start my presentations with a little icebreaker. Pardon the tiny print here. But on the chat, first of all, I'd like to ask if you could post as to which is your favorite language that you code in. So if let's say you were in an interview, you were invited to an interview and you had to program. Okay, Ruby, Python. Okay, keep it going. All right, awesome. Wow, we have an interesting mix. Cool. All right. So here I'm just sharing the Zen of Python. For those who have programmed in Python, familiar with this. Can you pick your favorite Zen? I know it's a long list, but you can just pick one and let us know. Currently, my favorite is in the face of ambiguity, refuse the temptation to guess. And this is something that could happen in a coding interview when challenged with a question. If it is ambiguous, please clarify. Refuse the temptation to guess. So currently this is at the top of my list. All right, explicit is better than implicit. Awesome. Readability counts. Excellent. All right. So I'm just going to share a brief agenda for today. We're going to start off with an overview of trees. And I am not going to do too much of the talking. I'm going to actually delve into the actual doing. So I want to simulate an interview and then share with you the best practices on how you can crack that interview. All right? So let's get started. So this is going to be an interactive session. So I am going to be putting you to work. And so the first thing I need you to do is, I'm assuming, and I expect everyone to be in front of a computer screen. So if you can just take a screenshot of this image. So this is an image of a tree. So just take a screenshot of it so that you have it for reference, because we're going to be referring to this in the subsequent slides. All right. Now, if everyone's done that, I'd like to, let's see if we can get some, I'm looking for reactions, but okay, can find it right now. But anyway, we'll get started with just definitions. So what is a tree? A tree is an undirected graph in which any two vertices are connected by exactly one path. In other words, any connected graph without simple cycles is a tree. So really, trees and graphs kind of go together, but what distinguishes a tree from a graph is that the tree cannot contain cycles. And there are two kinds of trees that I would like to first start off with is the n-ary tree and the binary tree. And I'm also going to borrow something from the Cracking the Coding interview. So so the focus, remember, here is on cracking the coding interview, literally. So one of the quotes from that book is, fluency in implementing a tree from actually, there's a typo here. And it is not from graph. It's a tree from scratch. Implementing a tree from scratch is essential. So we're going to make this interactive here. And for this, I'm going to need you to do something. So open up your favorite editor. It could be Notepad. It could be a Google Doc. It could be a Jupyter Notebook. Just any editor where you can type in some pseudocode. And I'll give you just a few minutes to do that. I'll explain why. So I'm going to be doing the same here. So I will be using Jupyter Notebooks, all right? So I have a Jupyter Notebook. I will switch to pretty soon. All right. Resume my share. All right. I think I just lost my window. Just give me a minute while I get to it. All right, there you go. All right. So I'm assuming that you have some editor open. Okay, it could be Notepad, as I said. So the first question for you is, you're given this tree, and we'll just go through a few basics. So at the very least, as far as the definitions go, a tree consists of nodes, right? And a tree you can have a single node, and it can have 0 or more children. Okay. Now, in the case of binary trees, you can have up to each node can have up to a max of two children. So here you can see that this is a binary tree. Each node is having like up to a max of 2. And you have these root, you have A as the root there. Go back. And then you have A, who's the ancestor of B. B is the ancestor of C. And likewise, B is the descendant of A, and C is the descendant of B. All right, now this is a binary tree. Now, what does an n-ary tree look like? So I'm just going to switch to LeetCode. And here we have the n-ary tree. So basically, you have nodes that can have multiple children. And so my first challenge for you is, if you were asked to represent a node in a binary tree, how would you do that? That's my first question. And the second question is, if you were asked to represent a node in an n-ary tree, that means multiple children, how would you go about doing that? And you can feel free to post your answers in a chat. So I'm going to let Alicia let me know as we get some responses on the chat.
I'm keeping an eye on that.
And you can use your language of choice to actually do this.
Could you share the LeetCode problem? I have the other problems, but just not the minimum height trees.
Okay, sure.
Well, actually, no, I'll search for it. I have that capability. You've got
Yeah.
Google.
But just to clarify, at this time, we are not solving any problem. We are just, I'm just going over some very basic concepts, right? So how do you represent a node, right? And to just get us thinking in terms of data structures. And I'm going to build this up slowly. So if you guys have had a chance to code.
We've got something in.
We've got something in the chat. Awesome. So
I can't tell you what language it is, but it is probably not Python.
This is looking fine. This is class node. Okay. I mean,
Yeah.
it's looking kind of close, but
Actually, no, it is Python. What are you talking about?
I actually asked for pseudocode. So yeah, this is good. This is good. All right. So what I'm going to do is now I'm going to share my Jupyter node. All right. Okay. So here we go. So I started off. So this is Python, and I started off with an entry node. So we'll be looking at, say, a root node that has multiple children. And so this representation would be, okay, I have my root node, it has a value, and it has multiple children. And to keep track of my multiple children, I'm going to be using a list. So that's what I have here. Then the next step is I just want to populate this particular tree. I want to build a tree, an n-ary tree. So I've just built this is my root node. And then I'm just I'm creating these additional nodes. And what I do is I just append it to the list. So if you can just imagine a visual of just a root node with 10 children, that's it. So that's your n-ary tree, where here in this case, n is 10. Now, in the case of a B tree, if you have that visual in mind, we have the root node, we have left and right. So here is your definition for the class, the B tree. And I'm really building a skewed left tree where my root node has a left node, and then I'm just building nodes from then on. So you can see here, again, I'm actually kind of chaining each node's left reference with the subsequent node. So and likewise, I have a skewed right tree. So that's what we have here. And it is always good to have just an idea of these dangling trees, because often when we are thinking of trees and we are solving problems, we're thinking of a balanced tree perhaps. But just having this idea in mind that you could be dealing with a skewed left or a skewed right tree is important. All right, I'm going to now switch to my presentation here. Okay, so next. So again, there are some more, this is just a repetition of what I've shared. So a binary tree is a tree in which each node has up to 2 children. A node is called a leaf if it has no children. And the application is appropriate when dealing with hierarchies. And especially when it comes to databases, trees are a big deal. Now, why are trees a favorite data structure for interview questions? So first of all, the solution for a problem that can be solved via trees, the solution is fairly compact. Now I'm talking about the recursive approach. It's fairly compact, but if a candidate just rushes into coding the solution, they can easily trip themselves. So when you get a problem, and it's the first step is to step away and just restrain yourself from going and coding immediately. It's better to start off with a document. That's why I have you open like just a document like Notepad, a Google Doc, or whatever, and just do the pseudocode and type in there. Also, in order to solve these tree problems, you have to demonstrate comfort with recursion and pointers. So pointers really something they borrowed from C++, but you're basically looking for, like in the case of Python, right? When you're keeping track of your left and right child, or even the root node, you have to check for none, right? If your tree is empty, or if you have reached the leaf node. Now, as far as trees go, there are some keywords to remember, and so I'm just going to go over them. Like, what's the depth? What's the definition of depth, the height of a binary tree, and what's a complete binary tree? So now we're going to just breeze through that, because these are important again when solving problems. So here, what's the depth of a node?
Daniella,
Yes.
You're intending to show the Jupyter screen, yeah?
Oh, I'm sorry. Is that showing right now?
Yeah, sorry. I was watching it and did not
Oh.
realize. Thank you for pointing that out in the chat.
Okay. So let me share it again. Okay.
It's always a challenge juggling multiple screens, especially when Zoom is like, you want full screen, right?
So let me do this. I'm going to resume the share, and well, why don't I stop share, and let's see, this time I should share. I wish it would just let me share everything, but let's work with
Does it not allow you to share your full screen? That's interesting.
So okay, just let me know if once you can see the presentation. Can you see the presentation?
Yeah, I can see it.
Okay, so I will just. All right. So you probably may have missed this part. So this is just the slide covering what I had gone over. So you haven't missed much. This is the important part. So these are the keywords to remember. So the depth of a node. Now in the diagram that I shared initially, and you have taken a screenshot, can someone share what's the depth of node n? So again, the depth of a node is a number of nodes on the search path from the root to a node, okay? Not including Z itself. And you can feel free to unmute yourself and share. So we'll just make it interactive. So what's the depth of node n?
Maybe I copied the wrong diagram, but I don't have a node n.
Oh my goodness.
I have up to F.
Oh my goodness. Yes, that was bad. So I'll just bring up this. So what's the depth of node D? So it's the number of nodes.
We've got 2.
Yes, 2, awesome.
We've got a 3. Anyone want to go for a 4? Sorry, not an option.
Okay, so for anyone who answered 2, can you share why it is 2?
Can I unmute myself?
Mm-hmm. Go ahead.
So if we're looking at D, the way I kind of look at it is to count the edges that you need to catch the root node. So from D, there are 2 edges up to the root node. So that's why it has a depth of 2.
Okay, that's one way of putting it. And the other way is, as you're traversing the tree from the root node to a certain node. Now it's interesting that this tree has all same values, but we're going to ignore that for now. They are duplicate values. it's actually just, it's the number of nodes from the root node to your node, excluding your node. So if I were to like traverse from root right up to this node, and I'm keeping track of the number of nodes that I have encountered, so it would be 1 and 2. And once I get to this node, then okay, you know, this is the depth. So like the root node is at a depth of 0. Then you have this is level 1, this is level 2, and this is level 3. Okay, so hope that helps clarify that. And then the next question would be, this is actually, let me first share something called the maximum depth of a tree, or rather it's the height of a tree. So if someone were to ask you, what is the height of this tree? So I'm going to give you the definition first. So the height of the tree is the maximum depth of a node in a tree. So that's simply put, how, you know, what is the maximum level, right? So here you have, let's look at these nodes. So I'm going to pick F. So F is E and F are at the lowest level. So what is the depth of these nodes? So for that, just count the number of nodes from the root to this node, excluding this node. So then we can say that the depth of this node is 3. And this is the maximum depth of the tree. And so this becomes the height of the tree. So just understanding this is important, so that if we are just asked a question, okay, I want you to go ahead and code a solution for the maximum depth, you should be able to do that. So we'll ignore that typo there. So here's the height of a binary tree. It's the maximum depth of any node in that tree. And then we also covered the levels of a tree. So all nodes at the same level. So for example, you can have nodes at level 0, 1, 2, 3 on that screenshot that we have. And I'm going to just go with this as well. What this is about, these are a few terms that we need to understand. I don't expect you to memorize it, but it is good to just be aware of it. So what's a full binary tree? A full binary tree is a binary tree in which every node other than the leaves has 2 children. So there you have it. Okay. So every node other than the leaves has 2 children. Now the perfect binary tree is a full binary tree, but all the leaves are at the same depth. So here's what you have here. And then the complete binary tree is a binary tree in which every level, except possibly the last, is completely filled, and all nodes are as far left as possible. So as you can see this. So if I were to get rid of node F, then yes, this would still be a complete binary tree. But if I got rid of D and E, then it's not complete, because the nodes have to be as far left as possible. Also, the difference between the left and the right subtrees, the height has to be less than or equal to 1. So here you will see this this term about the height of a subtree. So again, keep in mind the height of a tree is the maximum depth of a node of that tree. And then we're going to go to binary search. So first of all, I'm going to actually pause here and ask if anyone has any questions.
We've got a lot of numbers in the chat, so lots of guesses and answers.
That's great. I want to make sure everyone is awake. I'm sure you are awake, but I'm just checking. So it's good that we have an active audience. All right, now let's talk about binary search trees. A binary search tree is a binary tree in which every node fits a specific ordering property. So let's say n is the value of a node. All its left descendants should have values that are less than or equal to n, and n should be itself less than all right descendants. Now, this is not really set in stone, because your interviewer may have a different idea. In the sense, they might think, they might, from their definition, they might say, well, n could be less than or equal to all right descendants. So it's always good to clarify and say, it's my understanding that from, this, for the binary search tree, can I assume that this holds? Also check, so check if your definition coincides with theirs, and also ask if if the binary search tree can contain duplicates. All right.
Sorry, we have a quick question.
Yes.
Is the complete binary tree the same as a skewed left tree? So this particular diagram, is it a skewed left tree? And let me know if that wasn't the right question in the chat.
That is actually a great question. And I'm going to turn this around and I'm going to ask the question to our audience. And you have to just answer yes or no. Is a skewed, so first of all, let me ask this. Is a skewed left tree a binary tree? And so, a binary tree, each node can have up to a max of 2 nodes, right? So they could have 0, 1, or 2, or 2 children, each node. So I'm going to answer my question on that, and I'm going to say yes. So the binary tree could be skewed to the left. Next, the question is this skewed binary tree, can it be considered complete? So let's just look at the definition. A binary tree in which every level except possibly the last is completely filled. So what's going to happen with the skewed left tree, right? Sorry, pardon the expression. What's going to happen to our skewed binary tree? Basically what happens is you'll have A, I'm going to make C go away. I'll have B, and I'll just make E and F go away. Well, then what happens to these nodes here? Well, it's okay for the last level, right? The last level to be not filled completely. But then if you look at A is not filled, right? It just has B. It doesn't have a right child.
Sorry, just gonna recap. I think when you asked, is a skewed tree a binary tree? We had some answers. So I think those are the answers to that question. If one of you in the chat could confirm if that was the question you were answering. So I think the question is maybe an explanation of why the skewed tree is a binary tree. Also, if you can briefly go over what a skewed tree is, that would be helpful. Okay, so second question. All right, sorry about that.
Okay, so yes, I'll go with, I should have had a slide here for the skewed tree, right? But here's what we can do. We'll start off with the complete binary tree, and we'll make a copy of it, okay? And then we'll call this one skewed. Okay, so I'm going to get rid of this. So a skewed binary tree, and we want to make this a left skewed tree, right? Sorry, left skewed binary tree. Here's what I'm going to do. So if you'll remember that the tree that I built in that Jupyter notebook, where I first started off by building a root node, and then started creating these children and basically chained them such that the root node, its left field, the left, it referred to another node. So in C++, you would just call it, its left pointer was pointing to B, and then B's left pointer is pointing to D. So this is an example of a left skewed tree.
Thanks.
All right.
I think that clears it up for the one definition.
And
that
then
was
I will
missing.
put it here, a skewed, skewed tree is a binary tree. And this hopefully is clear because each node can have from 0 to maximum of 2 children. Okay, so we got that out of the way. And then the next question was, is the skewed tree, is it a complete tree, right? So this was the next one. And just if you just go to the definition of it, you can see it actually violates this one, right? This one, because every level except possibly the last should be completely filled. So when you look at the skewed tree, that is being violated. So yeah, does that make sense?
I'm gonna go out on a limb and say that it makes sense.
So this is actually an excellent question, because as we are going through the slides, they might seem, it might just seem just definitions of different words, but you can actually turn it around and create a problem out of this, and actually create a problem, something like, is this BST perfect? Check if BST is a perfect binary tree. Check if BST is a complete binary tree. Is this BST a skewed binary tree? And so on. So whoever asked that question, thank you for that. That was good. Okay. All right. So we're going to go, let me go back into presentation mode. So we went over this, like what's a binary search tree? It has this property. And basically the values in a binary search tree, if you traverse the binary search tree in a certain order, and we are getting to that, the values that you encounter will be sorted. So that's one of the important traits of a BST, a binary search tree. Now the binary tree traversals. So let's say you have this tree, and I can, I'm just going to go over the definitions, and then I will switch to that image of that tree that I started off with. So the searches can be BFS, so breadth first search, which is level order traversals, or DFS, which is depth first search. Now, for those who are more advanced and who are familiar with graphs and Dijkstra's and Bellman-Ford, all those algorithms, then those algorithms are using BFS, where they use level order traversal. For the sake of this presentation, I tried to keep it light, because this is the first presentation on trees, and depending on feedback, we can take it, like raise the bar and do something more advanced in subsequent presentations. So when we have to traverse the binary tree, as I said, we can go level by level, or we could do something called a depth first search. And for depth first search, you can do an Inorder Traversal, which is visit the left branch, the current node, and the right branch. And then you have pre-order traversal, in which case you'll visit the current node before its child nodes, and post-order traversal, where just the opposite. You will visit the current node after its child nodes. Okay, and so here, again, just keeping in the spirit of having everybody engaged, we are going to go back to that nice image, if I can find it. We are going to ignore all these values, and let's have some answers. I'm just looking for participation, and so we'll get started. And I want you, I let Alicia actually play. Alicia, yep. Which one should we do first, the in-order or the pre-order or the post-order?
In-order is tricky, so let's start with pre.
Okay.
Let's do pre-order.
Let's do pre-order. And while everyone's thinking about it, that's why you have that notepad or the Google Doc by your side. so that you can just crash into that and just, oops, sorry for changing that slide. Let's, oh, my sharing has paused. I'm having a lot of fun with my sharing. Okay, I'm gonna stop touching the screen, and your challenge is to share the list of nodes that you would encounter if you were doing, I think Alicia chose pre-order, correct?
Yes, I chose pre-order.
Okay.
For better or for worse.
So would somebody in the audience like to lead this? So in pre-order, you visit the root node before you visit the child nodes. So it's root, then left, then right.
So I guess the first will be A. I think I can confidently say that's going to be the first.
Yes, very good. Excellent. So
we have one answer that's
okay.
A, B, C, D, E, F, G. So we've got the alphabetical order.
You do?
Yes.
Okay. See, it was as easy as A, B, C, D, E, F, G. All right. So here's why. So you go to, we have the root. So that is actually the correct answer. So we start off with the root node A, correct? And then I'm going to go left, right? A, B. Now, whenever I encounter the node, I first visit that node itself. So in this case, by visit, we are saying we are printing out the value. So I will visit B, and that's how we have the answer B. Then I'm going to go to its left, and so that's how you have C. Then so in this case, you go B, C, and then we have now we come to D. Now, this is interesting. So when you come to D, let's apply the same rule. So I'm going to visit D, and then I'm going to visit its, let's go to its left node. So here's E, and then it's right. So likewise, and then we kind of, will recurse back up there. And so finally you have G. Now it's, if you had difficulty just going through this exercise, then perhaps you can just start off with a smaller tree. Just start with just 3 nodes. Just start with, for example, A, B, and G. Or for example, just start off with a single node, A. So the answer would be A. Let's say then you have B and G. You have, then when you traverse, it'll be the root, left and right, A, B, G. However, these trees are a classic case of for recursion, right? Where you can build the solution by solving sub-problems. So for example, I go to node A, I print out its name, right? It is A. And then I say, okay, node B, I'm going to do the same, apply the same algorithm for node B. Imagine as if like node A did not exist. So for node B, I'm going to do the same thing. I'm going to print its name B and then go to C. Now, in the case of recursion, we know that at some point, the recursion has to stop. You need to have a base case. And what's that base case? When you go past the leaf node and you encounter, in Python, we would just call it none, right? There is nothing past this. That's when your recursive tree will begin to unwind and you kind of return back. So solving a binary tree problem will really challenge your ability to program recursively. And so that is actually one of the requirements, just to be really comfortable with recursion. Okay, So having said that, this was the Inorder Traversal. Good job on that one. Next, let's do the,
That was the pre-order.
sorry, pre-order. I tripped myself.
I mean,
That's the pre-order traversal.
the alphabet looks nice like that. You want it to be in order.
Yes. So actually, yeah, that was the pre-order where you visit the root nodes before the child nodes. Thank you, Alicia, for checking me on that. Okay, the next one I'd like for us to do is post-order. So let's do post-order traversal. Okay. So in this case, when I visit the root node, I am not going to do anything with it. It's like I'm going to almost put it away on a stack. I'm going to actually go visit its left, and then I visit its right. So how do you think that list of nodes, what is it going to look like in the case of a post-order traversal? So post-order traversal really is left, right, and then the root node. Okay, so let's see what happens here. And just in the interest of time, and because I don't have animations, I'm just going to simulate things here. Okay, so here I start off with the root node. I'm going to go left, right? Again, I'm going to go left. I encounter, okay, I can't go past this anymore. So what's my first node? It's going to be C. Sorry. Okay, so I have C for my post for my post order traversal. Now I go backtrack here. We are going to visit the right side here. Again, when we come to this node, we're going to go here to the left. Okay, so it's going to be E. And I'm going to give people a chance to continue, if you get the idea, to enter your answers.
We've got a few. We've got C, E, F, D, which is what you've got there, and then B, G, A. We have another one, G, F, E, D, C, B, A, with a correction to the other one. So we've got a couple of typos, perhaps. So yeah, we've got that one.
Awesome. And then since everyone seems to be following along just fine, we'll just go directly to the in-order traversal now. So the in-order traversal is, you go, traverse the left node, then the root, and then the right. So let's do that one. So if you were given the root node and you were asked to do an in-order traversal, what would that look like? And I'll let Alicia let me know when we have answers.
We have C, B, E, D, F, A, G, with 2 votes as the most popular answer.
Okay, awesome. So thank you for participating. So now that we know what these traversals look like, now let us translate it to code. Okay, so what I would like you to do is, in your document, just write down a function for given a node, and this is a binary search tree. We'll just assume that it's a binary tree. So if you're looking at the class structure, you'll have a value, you'll have left and right. So I don't expect you to code to write pseudocode for all 3. Just pick one favorite. It could be in order, pre-order, or post-order, and just put it in that document. And I'm going to ask Alicia, can you see my screen from LeetCode?
Yes, I can.
Awesome. Well, I'm going to make this vanish.
Could you zoom in a little bit?
Oh, sorry, yes.
Thanks.
Is this working?
That is perfect.
And Alicia, perhaps could you share the link to this one if you have LeetCode open?
Sure, yeah, I'll grab it.
Thanks. So again, as far as best practices go, when you're given a problem or you're trying to solve a problem, let's say even it's on LeetCode, at least this is what I found that is most effective for me. I do not go and code in the LeetCode in this editor. I actually borrowed one of the tips that actually Alicia gave in her previous presentation, where she recommended just staying away from the computer and just writing out the code on paper, because that challenges you to get your syntax right. Many a time, I would have just made kind of like a syntax error. Instead of putting a colon, I'll put a semicolon, because that's just something that carried over from the C++ for me. So I will do that. Or I might just miss a particular step, especially with recursive functions. I might just miss some step where I forget to call the helper function, or I'm not returning the right value. So that's why I have this, I got rid of the code from here, and I'm hoping that you're coding something in your favorite editor. And if you have a solution to share, again, it can be pseudocode, doesn't matter. Feel free to post it on the chat. Alicia, sorry, I'm sure the chat is going to get pretty busy. I'm expecting.
That's okay.
All right.
The interesting thing is thinking about how this looks recursively versus iteratively. Mm-hmm. So the interesting way is if you do it recursively, you can challenge yourself to do it iteratively. And if you do it iteratively, you try to do it recursively. Yes. And for anyone who's a little earlier on in their interview prep, recursive means when you write a function and it calls itself. So that's something we can go over in more sessions later.
Yes.
So far, no answers, but I think that it takes everyone to code a little bit.
Yes, absolutely. And I'm going to ask for a time check. How much time do we have?
We have about 15 minutes, and then we'll wrap up.
15 minutes. All right, awesome. So here's the answer for the in-order traversal. I jumped directly to the answer. So as Alicia mentioned, when you say a function is recursive, it means that this function you can actually call itself. So here, for our in-order traversal, by the definition of our in-order traversal, what we want to do is when we encounter a node, we are going to first visit its left, then we're going to visit the node itself, and then we're going to visit its right. So here, I've used a recursive approach. Here's the in-order traversal. Now, first of all, when the problem is given, let's say the problem is given to you, right? They may not give you this actual function signature, or they just might. But based on the question, you will have to actually write down the function. So, for example, if the question just said, just print, I want you to just print the values of the nodes in this tree using in-order traversal, then this would look slightly different. As I traverse the tree, I would just do something like print root.val. Okay, but however, in this case, LeetCode is it's specifically saying return the in-order traversal of its node's value. So what's the return value of this function? It's a list. we want to return the list of values. And again, here, when we're looking at the in-order traversal, if I were to start with 1 and I go left, well, there is nothing out here. So that's where I'm actually going to return back. So one of the characteristics of a recursive function is recursive functions are applicable when you can apply the same logic to similar problems. So for example, each node here in this tree could actually be the root of another tree. Right? This is definitely the root of this tree, but then this is the root of another subtree. So recursion is useful in that cases because you want to basically apply the same logic to each of these nodes here. So here in this function, in-order traversal, here's what we got. We first start off with a signature. I know that I'm going to be given a root node, and what has to be returned is the list of all these integers. So make sure we got this right. The next is check for edge cases, right? So always good to ask, and this is a nice way to just have the conversation with your interviewer, and you can say, okay, well, there's a possible, could it be empty? This binary tree could be empty. In that case, right here, I can add my check here, and I can say if root is none, I'm just going to return an empty list. Now, here's something to pay attention to. As we are visiting each of these nodes, I have to really collect that information from these nodes and put it in a list. So in this in-order traversal, for Python has this ability where you can have an outer and an inner function. So I have this result, this variable, which is a list. And since helper is an inner function, helper has access to result. So result is a list, and I can update result from inside this helper function. So here is my helper. This is like the recursive function. It is again, as I said, every recursive function, you need to have this base case, because you could go on recursing from this node to this node to this node, but you need to know when to stop. So in this case, let's say I were to recurse all the way up to node 3, and then I go left of node 3. Well, there's nothing here, so it is none. At that point, I can actually return. So this is where the stack will start unwinding. So by just our definition, we say we want to explore the left subtree, the left subtree first. Then I'm going to visit my root node, and then I'm going to visit my right subtree, and that's effectively what it's doing here. So this is how it's actually working. And here from in-order traversal in this function. So this is just my helper function. This is just a function. It's not being executed at this point. So here I'm going to call helper. I'm going to pass in root. It's going to do all its work. And then finally, we're going to, it would have accumulated the result, and we will return the result. So I did not ask this at the beginning, but perhaps I should have asked as to how many of you are comfortable with recursion. But it would be interesting to get that idea, Alicia, so that perhaps in a future presentation, maybe we can cover recursion and things like dynamic programming. So
lots of topics.
Yeah, but I think with these different data structures, everything builds up on the other, and this does require that knowledge, at least in the context of this problem. Okay, so here we go. Now, in the interest of time, what I'm going to do is I'm actually going to fast forward a little bit. And I do appreciate everyone staying with me so far. But at this point, I'm actually going to bring up a video. And
do you know what?
Alicia, let me know if you can see this video.
I can see the video.
Okay, now just listen to
the scariest thing in the world is not knowing how to invert a binary tree in a coding interview.
Okay, did you hear that? It said the scariest thing is not knowing how to invert a binary tree in a coding interview. So guess what we are going to do? We are going to invert the binary tree today. And for this, what we will do is we will, oops. Okay. I have to bring up a document that I had actually shared with Alicia. So bring up my Slack. Okay. Okay, so here you go. Can everyone see? Alicia, can you see my screen?
I can.
Should I zoom in a little bit?
Oh, zooming in is great. I just don't have, we'll talk about sharing this later, but I do not have access to this.
Yes, absolutely. So here's an invert binary tree, and I need to keep track of time. It's okay. All right. So that was just, I just wanted to just share that with you. There's a big history about this particular problem, and you can read more about it on LeetCode. Actually, there's a reference to somebody who was challenged to solve this problem. I think it was at Google. Okay, so here's invert binary tree. Here's the problem. So first of all, when you hear this word, invert a binary tree, and I'll be honest with you, when I heard invert a binary tree, I'm thinking invert, okay? That's it. That's not what it is. So invert a binary tree is really a mirror image of the left and the right subtrees. So that's key to understand. It's a mirror image. So when let's say you were asked this question, I want you to invert the binary tree. So the first step is, let's go with the examples, right? So here are the examples, you're given this. So 4, 2, 7, 1, 3, 6, 9. And let's see what happens here. So I seem to have, I was playing with this tree a little bit. Okay. So here's what the expected output is. You have 4, okay? You have 7 and 2. And here what we are seeing is, you have 9, 6, 3, 1. But let's look at it more closely. Let's look at it from the bottom up. So let me look at this particular subtree. It's rooted at 2. What happened to this 1 and 3? Well, 3 and 1 looks like it's switched. 3 got switched with 1. What happened here? 6 and 9. 9 and 6 got switched. And then what happens here? So when you have, let's go up to their ancestors, right? So you have 2 and 7. Then you have 7 and 2 have switched. So in the binary tree, we know each node can have, so first of all, this is an example of, it is just this particular one, of a perfect binary tree, right? So every node, every level is completely filled. It just so happens this is a perfect binary tree. Now, as you are going through this input, and there's an additional example as well, I think, on the LeetCode. I'm just going to, let's see if this comes up. But I don't want to share the share the answers, so I'm just going to leave it as this. So as you're looking at this, you can see that there's something happening, and what it is does somebody want to guess how could I translate this to a pseudocode that can make this happen? And for the purpose, in the interest of time, we're just going to follow a recursive approach. And again, recursion is applicable when you can take a problem and divide it into sub-problems. So just imagine I did not have this 4 here. I just had a single tree rooted at 2, and it had 2 nodes, 1 and 3. And I was asked to invert this tree. So anyone want to give me an answer? You know, what would happen? You can unmute yourself, or I can ask Alicia. Alicia, if I have 2, 1, and 3, when I invert it, what needs to happen?
The right nodes, the left nodes need to become right nodes.
Yes, exactly. So so that has to happen. And if we can do that for the tree that is rooted at 2, do the same thing for the tree rooted at 7, and then repeat the same process for the tree rooted at 4, we would have an inverted binary tree. And so this is a great candidate for just using the recursive approach. But as I said, before plunging into the solution and just coding, it's important to just get an idea of what is the requirement here. What do we need to do? Again, we've also talked about traversals of a tree. And we have different kinds of traversals, right? You could visit the root node first, then the left, then the right. Or you could visit the left, then the right, and then the root node. And so the question to ask is, what kind of traversal do we want to do here? Okay. Because as I'm encountering these nodes, do I need to take any action as I visit these nodes? And lastly, what is my base case like? Now, in the binary tree, you know, once you go past the leaf node, you are going to return. But are there any values that I have to store? What is my what is the signature of my function going to look like? So these are all the things you have to consider. So here we know that this is we are going to be modifying this tree in place. So even if I had to return something from this function, I would be returning the same node back, because it's just the same tree, but the tree would have, it's almost, we have modified this tree, right? So that's what we would actually return. Okay, so now here let's look at a post-order traversal where and I'm actually giving you the answer because just in the interest of time. Why did I choose post-order traversal? So first of all, I need to do a depth first search because I need to go all the way down to my leaf nodes. So there you have it. It is a DFS. However, the second reason why I'm going to choose the post-order traversal is because that decision that I make at the root, it has to happen last. I have to first work on my left and my right subtrees, and then I get to my root node, and then I can make a decision of switching left. I'm going to borrow a term again from C++. Your left pointer and your right pointer. You could call it your left reference and your right reference. Okay, so just giving you working through the thought process here. So we got left, right, and then the root.
Just another minute, and we'll have to wrap up.
Okay. So now, I'm just going to breeze through this. So you're going to recurse the left subtree, recurse the right subtree, and like Alicia said, once you get to your root node, you just switch your left and your right. And so this is really what this solution looks like. If you remember the previous one, this is going to do something similar. We have an invert tree here. This is our helper function. Okay, this is using recursion. But the steps are, it's a post-order traversal. We're going to recurse my left subtree, recurse the right subtree. And once I get to my root, then I'm going to just switch. So this is the Python way you can, this is the way of swapping the left and right nodes. And then here's where I'm calling my helper function, and I return my root. Like I explained, we're just modifying the tree in place. So, and then the time complexity is O(n) because I do have to visit every node in the tree. And the space complexity is actually, it depends on the height of your subtree, because you're recursing depending on how low in that subtree you gotta go. So that's your space complexity. With that, I am going to turn over control to Alicia. I thank you for for being such good participants. I hope you enjoy the presentation. I will be sharing the slides with Alicia, and she can probably share it with you as well. The last thing is, before I just end, is I do attend a number of meetups, and there was a presentation given by Women Who Code Silicon Valley. And this guy's name is actually, his name is David. And he does, he had a detailed document explaining trees concepts, as well as there is actually a video recording of his entire presentation. So, however, this runs for over an hour. So I will be sharing this via Alicia to you guys as well. And please feel free to refer to it. So with that, I'm going to stop my share. And
thanks, Daniella. That was great. Definitely a forest of trees for sure. There's tons of kinds of trees, and unfortunately, or fortunately, depending on your interest in trees, it only scratches the surface really. And hopefully we can get into it more. There's really no end of interview topics that we can go over, which leads me into my wrap up. I want to know how you like to study for technical interviews. I want to make sure that for these presentations that we cover what helps people most. Maybe we start different event series. There's been a lot of requests for breakout sessions to do problems. And so we are limited by people for breakout sessions. So if you feel like you're willing to volunteer, please join us, and we'd be happy to have you facilitate. Just one final note. I'll just stop recording. Thank you everyone for attending. I will post the recordings later.